Everyone, welcome to this video. This is lecture number 77. Already 76 lecturers covered to solve the supplementary problem of the book Vector Analysis by M.R.Spiegel. You know this book is very important for physics as well as also for mathematics. Also important for IIT JAM examination. That's why we decide to solve the supplementary problem of this book. And the link of the previous lectures given in the description box. I refer to you, go to the description box and get the link, and you can see all the previous lecture from the playlist. Okay, so in this video I want to solve the supplementary problem 7.53 to 7.54, which consist in this chapter 7 of the curvilinear coordinate system. Okay, so let's start with question number 7.53, which says that prove that it's necessary and sufficient condition that a curvilinear coordinate system be orthogonal if that GPQ equals to 0 for this. You know, if you watch the previous lecture, from the previous lecture you can know that the square of arc length which is written as ds square, this is nothing but dr dot dr, and this can be written as this. There will be 9 terms, and in summation form you can written this as the summation p is equals to 1 to 3 and summation q is equals to 1 to 3 gpq dup. These are the coordinates 3, and this gpq is known as the metric coefficient, right? And you know, in case of orthogonal coordinate system, this will be written as hu square du square plus hv square dv square plus hz square dz square, like so. You can see there only if they are equal, this is exist, and the interchanging term which are will be 0. So g11 which is hu square, g22 which is hv square, g33 which is hz square, right? And the other terms will be 0, and the other terms will be 0, right? So that's it. And here question is called sufficient necessary condition, but I don't know how to prove this at this moment. If anyone can do this to prove this one, please comment in the comment box. I want to keep this question at this moment. Go to the next question 7.54, which says find the Jacobian for the cylindrical, spherical, parallel, and so on. So at first we choose the cylindrical coordinate system. At first we choose the cylindrical coordinates. In the cylindrical coordinates, the coordinates will be rho, phi, z. You know very well. If I want to draw the x, y, z, and this point, the rho will be this, and phi will be the angle with the x-axis, and z is the distance, right? So the equation will be x will be rho cos phi, this is rho, so this will be rho cos phi, and this is rho sin phi. So rho cos phi, y is equals to rho sin phi, and z is equals to z. You know that. So Jacobian, the definition of the Jacobian, from the definition of the Jacobian I want to write here. The definition of the Jacobian says that J x y z u1 u2 u3, this is nothing but del x del u1 del x del u2 del x del u3. and del y del u1, del y del u2, del y del u3, and del z del u1, del z del u2, del z del u3, right? So I want to find out this. So here this is nothing but u1, sorry, u1 is rho, this is u1, u2 and u3, right? So we need to find out this partial derivative. So the partial derivative del x del u1, that is the rho, del x del rho. What is the value of del x del rho? That is cos phi. Del x del phi, so this is minus rho sin phi, and del x del z, this will be 0. Similarly, del y del rho, this is sin phi, del y del phi, this is rho cos phi, and del y del z, this is 0, and del z del rho 0, del z del phi 0, and del z 1. Put this value in this Jacobian, J will be just cos phi minus rho sin phi 0, cos phi minus rho sin phi 0, and this will be sin phi rho cos phi 0, and this is 0 0 1. Just multiply with respect to this column, that is 1, that into that minus that into that, so rho cos square phi minus minus plus rho sin square phi. So common rho as a common, cos square plus sin square is 1. So this is the value of the Jacobian in case of cylindrical coordinate system. Go to the next one, that is the spherical coordinate system. Spherical coordinate, right? In the spherical coordinate, you know r theta phi, you know the r theta phi, this is the r, theta is this angle and phi is the angle from that, and the transformation you know very well, the transformation will be x equals to r sin theta cos phi, y is equals to r sin theta sin phi, and z is equals to r cos theta, right? This is theta. So we want to find out del x del r. What is the value of del x del r? That is the sin theta cos phi, right? Del x del theta, that is the r cos theta cos phi, and del x del phi, that is the minus r sin theta sin phi. Del y del r, that is sin theta sin phi, del y del theta r cos theta sin phi, and del y del phi r sin theta cos phi. Del z del r, that is cos theta, del z del theta, that is r minus r sin theta, and del z del phi, that is 0. Clear? Now put this value in the Jacobian. So the Jacobian will be, put this value, that is sin theta cos phi, sin theta cos phi r cos theta cos phi, do yourself and check with this answer, minus r sin theta sin phi, and sin theta sin phi. This is r cos theta sin phi. If there is any problem, you must comment in the comment box. Cos phi. This is cos theta minus r sin theta, and this is 0. And expand with this column, so you will get cos theta within bracket r square cos theta. So this is r square sin theta cos square phi minus minus plus r square sin theta cos theta sin square phi. Okay, and for this minus will becomes plus r sin theta. This will be gives you r sin square theta cos square phi plus r sin square theta sin square phi. Okay. So this is cos theta r square will gives you r square sin theta cos theta plus r sin theta, and from here r sin square theta. So take r square sin theta as a common within bracket cos square plus sin square, which give you 1. So the cos square plus sin square, which is 1. So this is the value of this Jacobian. Clear? I think clear. If there is any query, you must comment in the comment box. Go to the next one, which is C, paraboloidal. C is the parabolic cylindrical. For parabolic cylindrical, you know that will be u, v and z, and the conversation of this paraboloidal will be x is equals to half u square minus v square, y is equals to uv, and z is equals to z. Okay, and just derivative, the del x del u, this is u, del x del v, which is minus v, and del x del z which is 0, del y del u which is v, del y del v which is u, and del y del z which is 0, and del z del u 0, del z del v 0, del z del z 1. Just put this value in this Jacobian. So the value will be u minus v 0, v u 0 0 0 1. So expand with respect to this column, you will get 1 into u square minus 1 minus v square. So this is nothing but u square plus v square. I think clear. Go to the next one. That D says elliptic cylindrical. For elliptic cylindrical, you know the coordinate written as the u, v and z, and the relation with this are written that x is equals to a cos hyperbolic u and cos v, y is equals to a sin hyperbolic u sin v, and z equals to z. Do the partial derivative and find the Jacobian. First you, then you check. Okay, at first you need, I want to refer you to find yourself first. So this will be the cos hyperbolic u derivative will be sin hyperbolic, so this will be sin hyperbolic u cos v del x del v, this is minus a cos hyperbolic u sin v, and del x del z, this is 0. Similarly, del y del u. This is a cos hyperbolic u sin v del y del v. This is a sin hyperbolic u cos v del y del z equals to 0, and put with respect to z. So del z del u, which is 0, del z del v, which is also 0, del z del z, which is 1. Put this value in the Jacobian. So the Jacobian will be, put this value in this Jacobian. A sin hyperbolic u cos v minus a cos hyperbolic u sin v, and this is 0, and this is a cos hyperbolic u sin v, a sin hyperbolic u cos v 0, and this 0, this 0, this 1. So you will get that into that, that is the a square sin hyperbolic square u cos square v plus a square cos hyperbolic u sin square v. So just interchange sin cos into sin. This is 1 minus sin square, 1 minus sin square v, a square, that is 1 plus sin hyperbolic u, and it is sin square v. So if you expand, that is x square sin hyperbolic square u minus a square sin hyperbolic square u sin square v plus a square sin square v plus a square sin hyperbolic square u sin square v. These two are cancelled out, you will get a square sin hyperbolic square u plus sin square v. This is the Jacobian of this system. Go to the next one, that is prolet spheroidal prolet spheroidal coordinates, right? So this is written as xi, eta and phi. The conversation is a sin hyperbolic zeta, sorry, sin eta cos phi. Y is equals to a sin hyperbolic eta sin eta sin phi. And z is equals to a cos hyperbolic zeta cos eta. Okay, so you need to find out this derivative. You need to just find out this derivative, that is del x. Just find out this derivative, that is del x del zeta. Del x del zeta is a cos hyperbolic zeta sin eta cos phi, del x del eta, which is cos. So a sin hyperbolic zeta cos eta cos phi, this is phi, and del x del phi, this is minus a sin hyperbolic zeta sin eta cos phi. And in case of y, del y del zeta will be a, this is cos, sorry, mistake, cos hyperbolic zeta sin eta and sin phi, del y del eta is equal to a sin hyperbolic zeta and cos eta sin phi, and del z, sorry, del y del phi del y del phi will be this cos. So a sin zeta sin eta cos phi. Similarly, del z del eta, sorry, at first zeta will be a sin hyperbolic zeta cos eta, del z del eta will be minus a cos hyperbolic zeta sin eta, del z del phi will be 0. I think clear. Just put this value in this Jacobian, that Jacobian will be, put this value in this Jacobian, that is a cos hyperbolic zeta sin eta cos phi, this is phi, and a sin hyperbolic zeta cos eta cos phi. Do yourself and just check with this answer. Minus a sin eta xi sin eta cos phi, and this is a cos eta xi sin eta cos phi, and a sin eta xi cos eta sin phi, a sin eta xi sin eta cos phi, and in this column a sin eta xi cos eta minus a cos eta, sorry, cos hyperbolic xi sin eta, and this will be 0. Just expand with this column. So this will be a sin hyperbolic xi cos eta within bracket a square sin hyperbolic square zeta sin eta cos square phi plus a square sin hyperbolic square zeta sin eta cos eta sin square phi. Simple. And with plus, this will be a cos eta xi sin eta cos hyperbolic, and this is sin eta a square sin hyperbolic square, not square, zeta cos hyperbolic zeta sin square eta cos square phi plus a square sin hyperbolic zeta cos hyperbolic zeta sin square eta cos square phi. So just common, take the common, we will be get like that, that is the a cube sin hyperbolic zeta sin eta within bracket sin hyperbolic square and cos square eta plus cos hyperbolic square zeta sin square eta, and just convert the cos into sin. We will be get like that, sin hyperbolic xi sin eta sin hyperbolic square zeta, and this will be 1 minus sin square eta, and this is 1 plus sin zeta sin square eta, and just multiply, we will get this answer, sin hyperbolic xi sin eta sin hyperbolic square zeta sin square eta. I think clear. If there is any problem, you must comment in the comment box. This is all about me. This is my contact details. You can contact with my WhatsApp number regarding any physics related question. And this is my YouTube channel details. Go to this channel, you get all the videos which already uploaded, and share this video to your friends so that he or she also get benefit from this video. Subscribe this channel if you new in this channel, and those who already subscribe, thanks for subscription, and press the bell icon to get the notification when I will be uploaded new video. So take care. We'll meet in the next video as soon as possible. Thank you.